I'll just do this. Oh yeah, and it doesn't let me go down that far. The max I can go is probably April 2nd. I'm gonna try it on my computer, see if I can go any lower.
Okay, sounds good. So I'm recording 19.0 if you need to go back and look at it again later. Okay, so if you have a number in front of sine or in front of cosine, a coefficient, we'll call it A. That's not going to affect the domain. The domain is still going to be all real numbers, but it will affect the range because the range would be between negative, the opposite of A, and then A. So if there's no number in front of there, there's an invisible 1. So it still follows this rule between -1 and 1, like above. But if there's a number in front of sine or cosine, that has an effect on your range. It can go higher or lower along the y-axis. Okay, so for a cycle, that would be a repeated I want to say cycle, a repeated portion of the graph. So I'm going to highlight on this graph an example of a cycle. So if it goes from, if you start from the y-axis, it would go like this. You guys see the highlighted part? Let me see. So this would be one cycle. So one cycle, if I say graph one cycle on the homework or on the final, that's all you would need to give for the graph. If I say 2 cycles, you might want to do this entire graph here. So this would be one cycle before it repeats the same pattern again. So if it starts at a high point, it goes down to a low point and then up to a high point, then it repeats that same pattern again. So that's one full cycle. The period is the horizontal distance of one cycle.
Mr. Morrison, is that because on the graph it goes from 0 to 2 pi?
Exactly. So this is all based off the unit circle. So every time you go around the circle, it creates another cycle. So good observation. Yeah, going from 0. So like if you were to do, well, I'll come back to that in just a second. So horizontal length of one cycle. So back to what Aaron mentioned, let's focus on the cosine. I'll do the sine graph. If you did sine of 0 on the unit circle, it would be 0. If you did sine of pi over 2, the y-coordinate on the unit circle would be 1. If you do sine of pi, the y-coordinate at pi on the unit circle would be 0. If you do sine of 3 pi over 2, at 3 pi over 2 on the unit circle, it has a y-coordinate of -1. And then if you do sine of 2 pi, you're back to where you started. You just made one trip around the unit circle when you do one cycle. So that was a very good observation. He noticed we're going from 0 to 2 pi. So this covers every single time around the unit circle. Then every time you do another cycle, it's just one more trip around the unit circle. So it creates, in science, you learn this as a wavelength. So, but all of this is based on what we did in Mod 18. So Mod 18 was the most important unit probably of the entire year in terms of getting you ready for pre-calculus, because you're going to spend a lot of time next year working with the unit circle. Okay, so based on what I just said and what Aaron asked, does anybody know what the period would be for the graph of y equals sine theta or y equals cosine theta?
That's the word on top of that. So blank look, try O. Oh. Where's your mouse?
You're okay, Sierra?
Yep, sorry.
It's okay. All right, so here, I'm going to give you a hint. This right here represents one period, the horizontal distance of one cycle.
Oh, it's 2 pi.
2 pi is correct. So very good. So for sine and cosine, their graphs always have a period of 2 pi. That's the horizontal distance traveled along the theta axis, the horizontal axis. For a sine, the graph of y equals sine theta, also for y equals cosine theta. For, if you have a b, the period, I'm just going to give it to you, is going to be 2 pi over the absolute value of b. You don't have to worry about the absolute value in this class because b will always be positive. But in pre-calculus, if you see a b that's negative, just make sure you convert it to a positive number. So you do 2 pi divided by b. B is the coefficient of theta from the formula. So 2 pi over b. Okay, so I'm about to clear this screen out. Are there any questions so far? Okay. Clearing out and going down. Like I said, this lesson should not take us that long. Okay, so maxima and minima, that's the highest point and the lowest point. So maxima are the high points. Minima are the low points. And then zeros and roots, those are the x-intercepts. So if you're drawing the graph of y equals sine theta, do this in green. If you're starting at the y-axis, it's always going to go this pattern. It's going to go 0, max. Actually, I should say when a is positive. It's going to go 0, max, 0, min, and 0. So this would complete one cycle. So when I ask for a 5-point graph, this is what it's referring to, one cycle. So a 5-point graph, you would plot 5 points and then connect it. That would give you one cycle of the graph. This is starting at the y-axis. For cosine, for both of these, it would go, you'd actually on the y-axis when a is positive. On the y-axis, you'll start with a max and then go to a 0. And then a min, and then a 0, and you always stop where you started. So if we started at a max, we're going to finish at a max, the highest point. So I'll do a quick sketch so you have a better idea of what I'm talking about. So this one would go like this. It would start at a max, 0, min, 0, and then max. That would be one cycle. For sine, if I can fit it somewhere, maybe I'll do it up here since I have more room. The graph would go like this. It would start at a 0, hit a max, 0, min, and then 0. That would be one cycle for your sine graph. So that's starting at the y-axis. So this is a 5-point graph. That gives you one cycle, one trip around the unit circle. Okay, so the amplitude is easy. It's just the absolute value of A. So A comes from up here. So the coefficient, the amplitude tells you how high or how low the graph can go. So the amplitude is going to affect your max and your min, how high and how low. So this one has an amplitude because there's an invisible 1 here. The absolute value of 1 just equals 1. And if there's an A here, it's just going to be the absolute value of A. So that could be, it's always going to be a positive number. But if A is negative, you make it positive. So that's 19.0. Any questions on this part here before we go to 19.1 A and B? All right, I'm going to clear this screen off. 19.1 A and B is a lot of the same stuff, just little twists. So I'll start up here. So the period and the amplitude. So we already defined period on the last page, so now it's a more formal definition. The horizontal length of the shortest repeating part of a graph, measured along the x-axis, sometimes called the theta axis. It's always a positive number. So the formula, if it's in radians, you do 2 pi over absolute value of b. If it's in degrees, instead of using 2 pi, you're going to use 360 degrees. It's the same formula, 360 over absolute value of b. So if the problem is in radians, you should do, or it'll probably tell you on the homework, if it says radians, use 2 pi over b. If it says degrees, use the formula 360 over b. So a lot of this stuff we've already talked about, so this should be review. So that's why this is going to go fairly quickly. So make sure you know amplitude. Here's the actual definition for amplitude. It's half the distance from the maxima to the minima. And it's always a positive number because distance is always positive. All right, so I'm going to go down to the bottom of this page. You can kind of look over everything else, but it's pretty much stuff we've already talked about. Okay, so when you're asked to do a 5-point graph, these should not be difficult. Most students do really well at these. Once you get the hang of it, it's not bad. So for this one here, if you're given the graph, so this is the problem, y equals 3 sine theta, and we're going to do it in degrees. It'll tell you in the directions to use degrees or radians. Okay, because it says it has an amplitude of the absolute value of A. In this case, my A is 3. That tells me it can go up 3 above the x-axis and down 3 below the x-axis. So when I'm labeling the y-axis, I'm going to go up 3 and I'm going to go down 3. So when we're doing a 5-point graph, that means we're going to do one full cycle. So from the 19.0 notes, for a sine graph, you're going to start at a 0. A 0 is another word to describe an x-intercept. So you have a 0. Actually, before I keep going, though, let's find the period. So it's 2 pi over b. To figure out what b is, it's the coefficient of theta. If you don't see a number in front of theta, it's just going to be 1. So this is 2 pi over 1. So amplitude is the absolute value of A. So the period is 2 pi over b. And make sure b is a positive number. So here our b is 1. So the period is 2 pi. So these are going to be points on the final. Just be able to state the amplitude and the period. You should be able to quickly determine both of those things just from looking at the function. Okay, so now to label the horizontal axis. Maybe I'll write that at the bottom of the page. To label horizontal axis. Divide period by 4. And that'll be your scale. So here, my period is 2 pi. So I'm going to divide that by 4.
Oh,
This-
Mr. Morrison,
Yes.
sorry to interrupt. Are we supposed to be doing it in degrees?
Dang. We are. Should I just, maybe I'll switch them since I already wrote this out. So let's do a good observation. Let's do this one in radians and we'll do the next one in degrees. I should have read the directions more closely. I apologize. So try in radians. Or should it said try in degrees, but we're going to do it in radians. Okay, so my scale is pi over 2. So that means when I'm labeling my axis, maybe I'll do it down here so it's not in the way of the graph. It goes pi over 2. Then you just keep adding pi over 2 to itself. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So 1 pi over 2, 2 pi over 2 is just pi. Then you have 3 pi over 2. And then 4 pi over 2. That's going to, 4 pi over 2 is going to simplify to 2 pi. That's once around the unit circle. Okay, so here, if you remember from the previous, from 19.0 notes, when you're graphing sine, when A is positive here, it's positive 3. You're going to go a 0, then a max at the next hash mark. So it's going to go max, and then you go 0, and then min, so that would be down 3 using the amplitude. And then you go to a 0. So this is what your one cycle is going to look like. This is most of what we're going to be doing in Mod 19. Make sure to put the arrows at the end to show what direction it continues in. So this is the basis for Mod 19, drawing 5-point graphs. Sometimes you'll have to do more than one cycle. We'll talk about that.
Mr. Morrison, good morning, and I hope you're doing well. But what if A was negative?
If A was negative, then it's going to go down instead of up. So don't draw this, but if A was negative 3, it's going to be a reflection on the x-axis or the theta axis. So it would go like this. So it would go 0. So every max would become a min. Every min would become a max.
Oh, okay.
And then the zeros stay the same.
Okay, thank you.
But yeah, we'll definitely,
Okay,
you don't have
thank
to
you.
write that. That'll mess up your notes. But yeah, we'll see some like, good question.
Gotcha.
So actually let me undo that because I don't want you to copy that down. Okay, the next one I'm going to remember to do this one in degrees. Okay, so this one there has an amplitude of 1. If you want to find the period here, I can write theta over 4. That's the same as 1/4 times theta. So can someone with their mic turned on tell me what is my B here? What's the coefficient of theta?
1/4.
1/4. So here, because it says in degrees, I'm going to use 360 over B. Make sure B is a positive number, but like I said, in this class, B should always be positive. But just for when you get to pre-calculus, know to take the absolute value of B if you see a negative B. So this is going to be 360 divided by 1/4. So we're dividing by b, which is 1/4. And then dividing by 1/4, that's the same as timesing by 4. So this one is going to have a period of 1080 degrees. So when you're doing, if you're checking your graphing calculator, on your graphing calculator, you'd want to change your window. Make sure you're in degree mode for this one. And for your X min, you would do 0. Your X max would be 1080. So you can see the entire cycle on the window of your graphing calculator.
Mr. Morrison, it's not 1080.
It's not? Oh, I was just kidding. It's 1440.
Yeah.
You thought, April Fools. I can still say that. It's the last day I can say that, right?
Technically,
No.
yeah.
I tricked you guys, except for not Ethan. So this would be 1440. I was thinking 360 times 3. So 360 times 4 is 1440. Okay, so now to label the horizontal axis, I'm going to take 1440 and divide by 4. And that's just going to be 360. So when I'm labeling my theta axis, I have 360. Make sure to include the degree sign. You just keep adding 360s. Your scale, 720, 1080, and then 1440. And this one here, because the amplitude is 1, you're just going to go up 1, and you're going to go down 1. For a cosine graph, it doesn't, on the y-axis, you don't start at a 0. You start at the max from the y-axis if a is positive, and a is positive 1 here. So we're going to start at the max. So it's going to go max, and then it's going to go a 0, and then it's going to go a min, and then a 0, and then a max. And the arrow has to go down from a max. It can't go higher than a max. So this is what your final graph is going to look like. So again, you can check this on your graphing calculator. You would graph y equals cosine x over 4. Make sure you're in degree mode. And then you would change your window. So your x min is 0, and your x max would be 1440. And then for your y min, you could do -1, and your y max, you could do 1. So it'd be good practice to check on your graphing calculator. This creates one trip around the unit circle for y equals cosine of theta over 4.
So that's the thing, like, I want to ask Linda. Linda,
all right, I'm going to mute everybody, so just make sure to unmute yourself if needed. All right, so any questions on this page?
Mr. Morrison, how would you graph it on your graphing calculator again? Because I'm kind of having some issues.
Okay, so first of all, make sure you're in degree mode. You're doing the second one, right?
Yeah.
You're doing the second one?
Yep.
Y equals cosine, so you do y equals cosine of x over 4.
Uh-huh.
So it should look like this if you can see it. And then you hit window and change x min to 0. X max should be 1440.
Oh, okay.
And then your x min, or your y min, -1, and your y max is 1. And then you hit graph, and the graph should look very similar to the one you have on your notes, like that. I don't know if you can see that okay, but if you can.
Oh, yeah, it looks the exact same.
Okay.
Okay, thank you.
Uh-huh.
Anyway.
All right, so any questions before I clear the screen? Righty, next page. I'll probably have you take a picture of this page for the extra credit. after you're done taking notes. So give you a little break in before we start 19.1b. So it goes pretty quickly. Okay, so this one here, the amplitude is the absolute value of 5/2, which is just 5/2. And for the period, this one it says degrees. So I'm gonna do 360 over b. So my b is 3, the coefficient of theta. So this is gonna be 120 degrees. So if I'm going up 5/2, that's the same as 2.5. So I'm actually gonna go up 3 to make sure I can cover 2.5. Then I'm gonna go down 3. That'll cover negative 2.5. And to label my theta axis, you always take your period and you divide by 4. So this is not actually one of your answers, but this helps you. You need to label the horizontal axis. So when you divide by 4, that's just going to be 30. I like to label it at the very bottom so I have more room for my graph. Or so I'm not going over the numbers on my graph. So it goes 30, 60, 90, and 120. If you want to check your work, the fourth number you get should always match your period. So we stopped at 120. That's the same as your period. So for drawing this graph, you have to ask the question before you do your points. Is this a sine or a cosine graph? So just to know that you're still with me, someone tell me, is this sine or cosine?
Cosine.
Cosine.
Cosine. I love the feedback. That was great. Thank you. So for cosine, on the y-axis, it's going to have a max. So it's going to go up 2.5. So you have to remember that your max is 2.5 here. That comes from your amplitude. 5 over 2 is the same as 2.5. So it goes max 0. Your min is going to be down 2.5. So right in between negative 2 and negative 3 is your minimum, your lowest point, lowest possible point on your graph. And then we're going to go to a 0, and then we're going to finish where we started at a max, up 2.5. And this graph is going to look like this.
No, wait.
Everyone's okay with the first one?
I have a
Just
question,
speak up
Mr.
any
Morrison.
question. Yeah. Ethan.
Yeah, Mr. Morrison, for the max, like, what is that exactly? I can't really tell.
It's up 2.5. That's the same as 5. So 5 over 2 is 2.5.
Okay, thank you.
So it can go up 2 point. The highest point has a y-coordinate of 2.5. The lowest point has a y-coordinate of negative 2.5. The amplitude is half the distance, or it's the distance from the x-axis to the highest point, or from the x-axis to the lowest.
Gotcha.
So you double it to get the total distance. Mm-hmm. All right, so on this next one, I'm going to do absolute value of 4.
Okay, and then to
Yeah. Go ahead.
And then to graph it, our x max would now be 120, right?
At our max point. Well, the x coordinate. There's more than one max point on the side. So it has the first max point has an x coordinate of 0. The second max point has an x coordinate of 120.
Oh, okay.
So yeah, just there's more than one maximum point. There's actually an infinite number because the domain is all real numbers. For the cosine graph, you just have to show 2 of the max points. For sine, you only have to show 1.
Oh, okay. Thank you.
Mm-hmm. Okay, so this next one is in radians. I'm going to use a slightly different formula. Instead of 360 over b, I'm going to do 2 pi over b. So this has a coefficient of 1/2. You can separate that from the theta. So it's 2 pi divided by 1/2.
No,
This
4
equals
pi.
2 pi times 2, good, which is 4 pi. So this would be your period for this equation, the horizontal distance of one cycle. And then to label your x or your theta axis, you take your period and you divide by 4. So that's going to give you the scale of your horizontal axis. So it's going to go 1 pi, 2 pi, 3 pi, and 4 pi. And then for the because the amplitude here is 4, I'm going to go 4 up and I'm going to go 4 down. So I can locate quickly my max and my minimum points. And this is a sine graph. So a sine graph is going to start at a 0. So it'll start at the origin. And then it goes, because A is positive again, it's going to go up to the max. And then the next hash mark is a 0. Then it goes down to the min. And then it's a 0. So it's going to look like this graph here. So we're okay with the second example?
Fantastic.
Awesome news.
Doing great.
Sounds good. All right, so the third example here, it says radians. So that means for my amplitude, the formula never changes. It's absolute value of A. So that's just going to be 2. And because it's in radians, I'm going to do 2 pi over B. For B here, there's an invisible 1 in front of the theta. So it's going to be 2 pi over 1, which is 2 pi. So now I have my amplitude, I have my period. So if the amplitude is 2, I'm going to go up 2 and down 2. My period is 2 pi. I'm going to divide that by 4 to figure out my scale on the horizontal axis. So 2 pi over 4, which is pi over 2. So I'm going to go 1 pi over 2. And then 2 pi over 2 is just pi. And then 3 pi over 2. And then 4 pi over 2, which is just 2 pi. So you just keep adding pi over 2. And we're doing another cosine graph. So cosine graph on the y-axis always has a max when A is positive. So this lesson, all of our A's are positive. So it's going to have a max here. And then it just follows the pattern. From a max, you always go to a 0. And if you've already hit a max, it's going to go down to a min, down 2. And then a 0, and then a max. And just make your nice curvy cosine graph where the arrows go down from the max points. So any questions on this one here before we do the last graph of this lesson?
I'm good. Thanks for being awesome.
Thank you. Everyone's okay? You guys are doing awesome like Ethan? All
I'm
right.
doing awesome, Mr. Morrison.
Thank you, Aaron. Always appreciate the feedback. Sometimes it gets awkward when I feel like I'm talking to myself on Zoom. So it's nice to know that people are with me. Okay, so my amplitude on the next one is the absolute, there's an invisible 1 here. So that's my A. So the absolute value of 1 is just 1. So for the period, this one is in degrees. You have to know if you're working in radians or degrees. So this one's in degrees. So I'm going to do 360 over B. So this has a B of 1/3. So that's the coefficient of theta. There's dividing by 3 is the same as timesing by 1/3. So this is the same dividing by 1/3 now. That's equivalent to timesing by 3. So this one actually will be 1080. So now I know my amplitude is 1. That tells me to go up 1 and down 1 on the graph. hopefully you've had a chance to try a few of these on your graphing calculator. So it's a very good skill to have, being able to correctly use your graphing calculator. It will help you immensely in calculus, and it'll also help you in pre-calculus. Okay, so 1080, you divide that by 4. What is this going to be? 270? Okay, so now when I label the axis, I have to write kind of small here. So it's 270, then you keep adding 270. So 540. I don't know how I'm going to fit this. 540, then you add 270 to that. That's going to give you 810. I'm a little bit off here. Hopefully you can write smaller than I can. So again, it says 270, 540, 810, 1080. And because it's a sine graph, it's going to intersect the origin. And A is positive, so it's going to go up to the max from the origin. So again, on the previous page, when I said 0, max, 0, min, 0, that's what we're doing here. So 0, max, 0, min, 0. This gives you one cycle, but know that this graph goes forever to the left and forever to the right. This one has a period of 1080. That's the horizontal distance we traveled. So, any questions here before I go down? And clear this screen off. Okay. So now we're working backwards. Here you have two equations, or two graphs, and you want to find the equation. So I'm going to start off by finding the amplitude. Don't confuse that with A, because amplitude is always positive. A can be positive or negative. So the amplitude is the distance from the x-axis to the max. Or you could also do from the x-axis to the min. So can someone tell me the amplitude here, the distance from the x-axis to the maximum point?
It's 3.
It is 3, that's correct. So, and because it goes up to the max, A would also be 3. So the domain, from that I can quickly tell the domain and the range. So the domain is all real numbers. So theta is all real numbers. For the range, y is between negative a and a. So negative 3 and 3. Okay, so now the trickiest part is finding b here. So to find b, I am going to highlight one cycle. Okay, so highlighting one cycle, it goes like this. So 0 hits a max, a 0, a min, and then back to a 0. Okay, so I want to know the horizontal distance that I traveled here. So can somebody tell me what my period is?
1440.
1440, good. Because you can hopefully tell this is 720. Then you add 720 of that, it's going to give you 1440. So the period is 1440. And see how you, if you notice there's a degree symbol. So that's how you know you're working in degrees. So the period is also, the formula for degrees is 360 over b. So if you want to solve, to get the equation, you actually care about what B equals. So if the period equals this, and the period also equals this, I'm going to set these two things equal to each other to solve for B. So 1440 equals 360 over B. And because I have a variable in my denominator, so 1440 equals 360 over B, I can use a little trick I learned back in Compton. So B is going to equal, you just switch the B and the 1440. So I call this the Compton trick. When the variable is in the denominator, just switch it with whatever is on the other side. And when you reduce this, this is going to give you 1/4. So now I have B, I have A, that's what I need to write the equation for my graph. And one last thing here. I'm going to write it up here. Is this a sine or a cosine graph? Somebody tell me.
Sine.
This is sine. Good. So this is sine because isn't it going through the origin? So it's y-intercept is the
Sorry to
zero.
interrupt.
It's okay. So that means it's a sine graph. So it's going to be A times sine of B theta. Whoa. So now I'm just plugging in for A and B and I'm done. So it's going to be A, which is 3, sine of 1/4 theta. A better way to write 1/4 times theta is just theta over 4. So this is the same as saying 1/4 times theta. So that would be your answer, and you can check that on your graphing calculator using the same window of the given graph. So like 0 to, what does it say, 2800 or something like that. Okay, next graph, we're doing the same thing. So my A here is going to equal, this one looks like it has a distance of 4 going from the x-axis to the highest point. So my A is 4. Because it's a max, and then amplitude is absolute value of 4, which is 4. So please note these, in this lesson, they're always the same, but starting next week, they're not actually even starting the next lesson today. They're not always going to be the same. So amplitude is 4. So now the period, let's see here, it goes max, 0, min, 0, max. So that's going to give me one cycle there. So max 0, min 0, max. And then the horizontal distance is going to be my period that I traveled. Okay, so here my period looks like it's going to be pi. So this one, there's no degree symbol, so that's how you know you're working in radians. So you can look at how the horizontal axis is labeled to determine if you're in radians or degrees. So this one's in radians. So when you're in radians, the formula for period is going to be 2 pi over b. So if the period equals this and the period also equals this, I can set these two things equal to each other. So I'm going to say pi equals 2 pi over b. I can use the Compton trick again. So pi equals 2 pi over b. So I can switch the b and the pi. So b is going to be 2 pi over pi. And that just simplifies to 2. So now I have my b and I have my a. Someone tell me, is this a sine or a cosine graph?
Cosine.
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 This one is cosine. Good, because the y-intercept is a maximum point. Even if it was a minimum, it would still be cosine. We'll look at that in the next lesson. So here, I'm going to use the formula for cosine is A times cosine of b theta. So y equals, I'm just going to plug in 4 for A, and then cosine of 2 theta. And you can graph this on your calculator, and it should match the given graph. Okay, so are there any questions before I clear this screen off?
You didn't do the domain and range.
You're right. So let's do the domain and the range. So the domain is theta is all real numbers. And then for the range, using the amplitude or using A, it's the opposite of A is the lower boundary. And then A is the upper boundary. So from -4 to 4. Okay, so anything else before I clear this screen off?
Are we gonna do
Okay, for the
19.1
extra
C?
credit, can you just take? We will, but not today. So we just have 2 more assignments or 2 more notes to complete next week, and that'll be it for notes for the year. Okay, so on the extra credit, it still hasn't come up yet. Oh, there it goes. The extra credit, you're going to take a picture of the page we just did, and then submit that on where it says 430 Zoom extra credit on Google Classroom. So just take a picture of this page of completed notes and then submit that. It needs to be submitted in the next 10 minutes. So just do that now. I'll give you a couple minutes before I start the next note session. So 2,000 extra credit test points. Just take a picture of this page of your notes, submit it on the appropriate assignment for April 30th. Needs to be done quickly though. Okay, so I'm going to clear this screen off. There's no. Okay, then 19.1b is pretty much the same thing we just did, so it should go quickly. It's just now we're going to work with negative a values. So it's going to involve a reflection on the horizontal axis. So we're going to move pretty quickly through this, and then we'll go over homework, and that'll be it for today. Okay, so 19.1b, you can kind of look over the top part again. That should be our review. I'll just add a little b here where it needs to go. So most of this, like I said, is all the same stuff we've been doing. So technically the formula is over absolute value of b, but again, I don't always put the absolute value bars because in this class, b is always going to be positive. Let's see here. Okay, so you see the graph of y equals sine and cosine. Remember, these graphs go on forever to the left, forever to the right. What we've been focusing on is drawing the graph of one complete cycle. That's called a 5-point graph. So it has like a max, a min, some zeros, some combination of those to get 5 points. Okay, so now going down, when a is negative, notice you have a reflection across the x-axis. So every max becomes a min, every min becomes a max. So what this is going to look like now, for sine, you're still going to start out at a 0 when a is negative. But then instead of going up to the max, you're going to go down to the min, the lowest point. So every 0 stays the same, but every max and min switches. So a max becomes a min, every min becomes a max. So it goes 0, min, 0, max, and then you always stop where you started. So if you started at a 0, you finish at a 0. And everyone should know a 0 is the same as an x-intercept. Whenever a is negative for a cosine graph, instead of starting at the max, someone tell me where you're going to start on the y-axis.
The min.
The min. So when a, this is when a is negative here. So you haven't had to worry about this until now. So when a is negative, for cosine, you're going to start at a min, and then it's going to go min, like miss min, then 0, and then max, and then a 0 makes you a minion. And then at the very end, you have max, or sorry, min. You always finish where you started. So if you start out at the min, your 5th point is going to also be at the min. So that should come up in a second, and then I'm going to clear the screen off. So again, for negative, anytime a is negative, it's going to go min, 0, max, 0, min. It's a pretty bad lag going on. There it goes. So I'm going to be moving pretty quickly through this. It's the same idea of what you've been doing. And then we'll should have plenty of time to go over homework, and that'll be it for today. All right, so I'm going to clear the screen off. So one big difference, amplitude. Don't miss this point on the final. This should be easy. Amplitude is always the absolute value of a. Don't assume so amplitude can never be negative. So if I ask you for the amplitude, that's a distance from the x-axis to the highest point. So distance is always positive. So absolute value of -2 is going to be 2. It affects your graph, the negative, but it does not affect your amplitude. So even though a is -2, the amplitude is just 2. So this one is in degrees. So for the period, I'm going to use the formula 360 over b. So it's 360 over 3, which is 120 degrees. Sorry, it needs a second to catch up to my voice. So 120 degrees. So just like we did before, to label the horizontal axis, you take the period and divide. So that's going to be 30 degrees. So when I'm labeling the horizontal axis, it goes 30, 60, 90, 120. And you should always, again, finish where the last number should be the same as your period. Because the amplitude is 2, I'm going to go up 2 and I'm going to go down 2. So I'm just going to put a hash mark there so I can see how high and how low to draw the graph. And the last thing you have to think about, is it sine or cosine? So this one is sine, so it's going to pass through the origin. But because a is negative here, after the 0, we're going to go down instead of up. So it's going to go down. This is the big difference between this lesson and the last one. So we're going to go down to the min. This causes a reflection over the horizontal axis. So then we go up, and then we go to the 0, and then we go to the max before we finish back at a 0. So this graph is going to look like this, and you can check this on your calculator. So any questions on this one here? Not sure what happened with my degree symbol. 30 degrees for the scale. So everyone's okay when A is negative. You'll remember when you're doing your final graph, for sine, you're going to go down from the origin instead of up, down to the minimum. Okay, for this next one, it's going to be in radians now. That's going to affect my period. It won't affect my amplitude. So it's the absolute value of -1, which is 1. So that means I'm going to go up 1 and down 1. If you want to change the scale, you could. I'll just leave it as by ones. So my amplitude is 1. Because it's in radians, I'm going to do 2 pi over b. Here my b is 1/3. Dividing theta by 3 is the same as timesing theta by 1/3. So it's going to be 2 pi over 1/3. Dividing by 1/3 is the same as timesing by 3. So that gives me a period of 6 pi. So that's going to be 1 trip around the unit circle when I move 6 pi units along the horizontal axis. So it's not technically a unit circle if it's not a radius of 1, but 1 trip around the circle. Okay, so I'm going to take my period and divide by 4 to label the theta axis. So this is going to be 3 pi over 2. So when I'm drawing my scale, I get 3 pi over 2. And then, so there'll be 3 pi over 2, 6 pi over 2, 9 pi over 2, 12 pi over 2. So 3 pi over 2, 6 pi over 2, that's the same as 3 pi. And then you have 9 pi over 2. And then the last one is 12 pi over 2. 12 pi over 2 is equivalent to 6 pi. So that's the same as my period. So when you're graphing cosine, your y-intercept is going to be a minimum. So it is -1. So we go minimum, 0, max, 0, min. And from a minimum, the arrow has to always go up. So it's going to look like this. So while I wait for that to show up on the screen, any questions so far? So we're okay moving pretty quickly through this lesson? Because you guys probably don't want to be here till 12. We definitely should be out well before 12. And plenty of time to go over the homework. Okay. So I'm going to clear this out. We do need to do a couple, so this is only 4 problems on the back side here. And this will be the last page of notes today. I know we're doing 3 sections, but 19.0 is just like an introduction. So that really didn't count as notes. That was super quick. All right, so right here, amplitude is the absolute value of 3.5, which is just 3.5. Or we're in degrees. So the period is 360 over b. My b is 4. So my period is just 90 degrees. And then to find my scale, I'm going to take 90 and divide by 4, which gives me 22.5. It's okay to have decimals. Sometimes you have decimals. So when I'm labeling my axis, I have to write small again here. So 22.5 degrees, then 45 degrees, and then 67.5 degrees, and 90 degrees. because my amplitude is 3.5, I'm going to make a marking up 3.5 and a marking down 3.5. So I don't have to think as much later. So I know how high to go and how low to go. So up 3.5 and down 3.5. So here my A is positive. So I'm going to, for cosine, I'm going to start at the max. So up 3.5 and then 0, down 3.5, and then 0, and then up 3.5. So this is going to look like this. For the next one, I'm going to do absolute value again. So even though A is negative, my amplitude will always be positive no matter what. So my amplitude is 3.5 here. So once again, I'm going to go up 3.5 and down 3.5. Because this one's in radians, I'm going to use a slightly different formula. So it's 2 pi over b. So my b is 1/4. So dividing by 1/4 means we're timesing by 4. So this is going to give me a period of 8 pi. That's how far I travel to go once around the circle. When you're converting it back to like the unit circle we did last week. So you take your period, you divide by 4. Hopefully this is easy for you now. We've done so many of these just in one day. So 2 pi, so it's going to go 2 pi, 4 pi, 6 pi, and 8 pi. So it's a sine graph, so we're going to start at the origin for our cycle. And because A is negative, we're going to go down to a minimum, and then to a 0, and then up to a max, and then down to a 0. So this is what your sine graph is going to look like. This is one cycle of your sine graph. One cycle of infinitely many cycles. So any questions before we do the last 2 problems of the notes? Everyone's doing okay? I need to hear somebody say something. You guys doing okay?
Pretty good.
Doing good.
What if I was on?
Yep.
What if I was on mute the whole time and didn't realize it? That would have been sad. It's nice to know you can hear me.
That would have sucked.
Okay, so I'm glad that wasn't the case. Okay, so the last 2 we're going to work backwards again. So I'm going to clear off the work at the top so I have more space. Okay, so here, first thing I'm going to do, it doesn't matter if you do this at the beginning or the end, but I'm going to tell from looking at this and pass this through the origin, this is a sine graph. So whenever it's a sine graph, you're going to use this formula, A times sine of B times theta. So A here, let's first find the amplitude. So the amplitude is the distance from the x-axis to the max. So that looks like it's going to be 1. So I'm going to say amplitude equals 1. Be careful here, though. Even though the amplitude is 1, if you look at the graph, it's a sine graph, it starts out going down from the origin. So what does A equal?
-1.
What's my A here?
-0.
-1. Good. Because it's going down from the origin.
Wait,
-0.5.
yeah,
The amplitude would be
Mr.
1.
Morrison,
But my A,
It's -0.5.
it's negative.
yes.
Wouldn't it be negative 0.5 based on the y-axis?
Is it really?
Yeah.
Oh, that's it. I thought that was a 2. That's a 1. Thank you. Okay, so JK. So my amplitude is 0.5. And then A would be -0.5. I looked at this number here and I thought that was a 2. I didn't look close enough though. So that's a 1. So yeah, it's going to be 0.5. Okay, so for the period, well, actually, first let's highlight a cycle. So one cycle would go from the origin, it goes 0, min, 0, max, and then back to the 0. So I want to know the horizontal distance that I traveled here. So if you see 120 and it takes 4 hash marks to get to 120, you do 120 divided by 4, your scale is by 30. So it looks like you're going 2 hash marks past 120. So you do 120 plus 30 plus 30. So that should be 180 degrees. Is that what you guys are getting for the period? 180? Hopefully. So the period is 180 degrees. So if we're working in degrees here, that means the
80,
formula.
that's 20 degrees.
Everyone's okay with 180? Halfway between 120 and 240, that should be 180. And you have to be able to identify one cycle. So once you go through your 5 key points, you stop. That's the end of this cycle. So the period is 360 over B. So because the period equals this and the period also equals this, I can set these two things equal to each other and use the Compton trick again. So 180 equals 360 over B. Using the Compton trick, B is going to be 360 over 180. That means my B just equals 2. So now I have everything I need to write my equation. So then I'll put my domain in my range. So Y equals, when I plug into the formula at the top, it's negative 0.5 sine, and my B is 2, so 2 theta. And you can check this on the graphing calculator. All of these domains are going to be theta as all real numbers. The range is based off of the amplitude. So it's going to be the opposite of the amplitude, which is negative 0.5. Or I should say, or equal. Hopefully I was doing that earlier. I think I was. Negative 0.5. And then the upper boundary is positive 0.5. Any questions on that graph? I don't want to go too fast to make sure we're okay. And we still have the homework to go over. Good. Okay, this next one, is it sine or cosine?
Cosine.
Cosine, thank you. Someone has noise in their background. Hopefully you can figure it out so I don't have to mute everyone. So it's going to be A times, it's okay. So A times cosine of B theta. So for this one, A looks like it's going to be 3 here. Actually, the amplitude is 3 because the amplitude is a distance. And then A is going to be negative 3 because the minimum is, the y-intercept is a minimum. So you have to make sure to look closely. So A is a negative number here. So that's what's going to be helpful for my equation, the negative 3. Because I have a minimum at my y-intercept. Okay, so now for the period. So I'm going to write 2 different formulas for the period. So first things first, I'm the realist. Drop and let the whole world feel it. So for my cycle, it's going to go min, 0, max, 0, and then min. I want to know the horizontal distance I traveled here. So I'm going to hear from you guys. Someone tell me, what's the horizontal distance I traveled for my period for one cycle?
8 pi.
8 pi, very good. So 8 pi is the horizontal distance traveled for one cycle. And so the period equals 8 pi because that's in radians. There's no degree symbol. I'm going to use another way to write my period is 2 pi over b. So to solve for b, I'm going to set these two things equal to each other.
Wait, Mr. Morrison?
Yes.
How come it's 8 pi, not 10 pi? I'm a little confused.
Because 10 pi, you're going too far. I'll cover the, let's see, I'm going to cover the 5 key points. So it's, you started at a 0, then a min, then you had a 0, then a max, then a 0, then a min. So you stop at the 5th point. So see how that's at 8 pi? So that's a 5-point graph when it goes min,
Oh, okay.
0, max 0. So that's a horizontal distance of 8 pi that you
Okay,
travel.
okay, thank you.
Okay, so here B is going to equal, the pi's cancel out, so it's just going to be 1/4. And now I can finish the problem and we'll be done with notes for today. So my A is -3. Cosine of 1/4 theta, rather than writing 1/4 times theta, it's more common to see this as theta over 4. It's the same as 1/4 theta. So this has the domain like all of the sine and cosine graphs do of all real numbers. For the range, you take the opposite of the amplitude. That's going to go first. So the opposite of 3 is -3. And then the amplitude is going to always be the upper boundary, which is +3. So any questions on the notes from today? Okay, so then we have, so the homework I sent you yesterday, so that's 19.1a, 19.1.
Wait, I have a quick question.
Yes. Go ahead.
So are all the domains going to be all real numbers, Mr. Morrison, always?
For sine and cosine graphs, yes, they will always be all real numbers.
Gotcha. Okay, thank you.
Okay, so let's switch over then to 18.4a. I'm glad Vanessa was able to do her homework. I love when Twitter goes down. Okay. So I have 18.4a. Here is 1 through 6.